Okay, so in this video, I'm going to take you through quite a bit of a lengthy process, okay, in producing the graph of the rational expression that you see listed there. The first step that I like to do is just, well, obviously you can't do anything unless you simplify the expression, numerator and denominator, and see what ends up dividing out. So first things first, let's just I'm going to write f of x here. Okay, it's already written, so I'm just sliding this down here. But what I'm going to do off to the side is identify um, the multiplication, like conditions and the addition condition. I'm just factoring, right? I'm factoring. So my first move, when I say the word simplify, is going to be to factor, basically. Okay. If you are looking for this video or the question sheet that comes with this, it is a CUDA sheet that's free accessible. So I can put a link, well, there'll be a link to it on my website. Two numbers that multiply to 12 and add to 7 sound like 4 and 3. Okay, so in the numerator, because the numerator is a simple trinomial, I can just replace x squared plus 7x plus 12 with x plus 4 times x plus 3, all divided by, I'm just going to factor the second one now. So the catch here in the second, in the denominator, just watch, because the denominator can be simplified to be, you can factor out that -2, and you're going to be left with x squared minus x minus 6. Plus x. Sorry. Okay. And so when we look at that, I'm looking for two numbers that multiply to -6 and add to +1. So that sounds like, to me, those two numbers are going to be -2 and 3. Okay, so the denominator is going to factor to something like this. X minus 2 times x plus 3. Okay, so this is your new simplified function. Okay, now there's a couple obvious things here, hopefully. State restrictions means any of the values of x that set the denominator equal to 0 we're not allowed to have. So one of them, x minus 2 can't equal 0, and x plus 3 can't equal 0. Okay, so what's going to happen here is that x can't equal 2 and -3. Okay, because those are the two values of x that set the denominator equal to 0, and we know we're not allowed to divide by 0. So something else happens here as well. The x plus 3's divide out. Okay, and so my simplified expression for f of x is going to look like this. X plus 4 over -2, x minus 2, where x can't equal 2 and -3. Okay, so that's your simplified expression. So right here, we'll try and eat that up. Okay, that's your simplified expression. Okay, and that's very important to be able to get to this stage, because we obviously can't produce a graph unless we can get there. Okay, so in the next step here, I'd say we're going to start listing some information, right? And so I'm going to say vertical asymptotes. Let's identify any vertical asymptotes. Well, vertical asymptotes happen where in your final simplified expression, they are the restriction that still exists in your simplified expression. And so we're going to see there's a vertical asymptote at x equals 2. Okay, now the other one that got canceled out, this is why it's very important for you to state your restrictions before you cancel out or divide out any of the factors, because the other one is what we call a hole. There's actually a physical hole in the graph, and it happens at when x equals -3. Okay, and the problem with a hole is this is actually a coordinal point. So what we need to figure out is where or what the y value is. And so what we're going to do is we're going to find y by evaluating f at -3. Okay, so what we're going to do to find the whole is f at -3 is going to equal -3 plus 4 over -2 times -3 minus 2. And we should see here, we get 1 over -2 times -5. And so we should get 1/10. Okay, so we're actually going to go to the graph. We're going to try our best to draw 1/10, that point. So we're going to see that the whole actually occurs. F at -3 is 1/10. Okay, and so we're going to actually go to that point on our graph and plot it. Okay, and we're going to see that we're going to get a hole at that particular value, which is kind of interesting. Some of us haven't seen that before. Okay, so we're going to actually plot that. The next thing we can figure out would be the horizontal asymptote. We learned that horizontal asymptotes, when the degree of the numerator would be determined by that leading coefficient. When the degree of the numerator matches the degree of the denominator, the horizontal asymptote occurs at the ratio of the coefficients. And so in this particular question, the horizontal asymptote is just a horizontal line, hence the y equals. You're going to get y equals -1/2. Okay. And then so that's that. Okay. What we could probably do at this point is go to our graph and just plot some of the information that I've just found. I'm going to get rid of this arrow because it is kind of clunking things up. So x equals +2. You're going to label that. Then you're also going to label, let's draw it purple, the horizontal asymptote right here at -1/2, sorry. Okay, so that's going to be y equals -1/2. Okay, so that's some information. But we could also draw on our point too, which we'll come back and do the points in a minute. Okay, so here's the next point of interest. Why did I count to 4 here? Let's go 3. Okay, the horizontal asymptote would be the third thing you look for, sorry. The fourth thing you're going to look for is x-intercepts. We know x-intercepts occur when y equals 0. Okay. So what we're going to look for here is we're going to set the equation equal to 0, preferably our simplified one, because that's going to be the easiest one to work with, right? We're going to see 0 is equal to x plus 4 over -2x minus 2. Now what we would be allowed to do, just like when we solve any equation, what's nice about having this 0 on the left side is that it's going to actually consume that denominator. So if I were to multiply both sides by -2x minus 2, you'll see that the 0 just eats that up, and these end up dividing out. So what we're going to see here is 0 equals x plus 4. Which means if I were to solve for x, I would see that x is equal to -4, meaning the x-intercept is going to be at -4, 0. Okay, so I could go plot that point. I'm not going to do that. -4, 0 is going to be right here. Okay, now the other one we could probably plot too, which is going to be a little tougher to plot, but nonetheless it'll be right here. Let's find this up. We could also plot -3 1/10. That would be our whole from earlier. Okay, so we get an idea. Okay, the other one we can do now is, as you would probably predict, might be the y-intercept. And we know at y-intercepts, x is equal to 0. And so I'm just going to evaluate my function at 0 and see what I get. Right? So I'm going to get 0 plus 4 over negative 2 times 0 minus 2. And I'm going to get 4 over 4, which is equal to 1. And so I actually get, when f is 0, the value of my function is 1. So I can go plot that point too. Up here. This graph's not too bad, actually. So right now, off the bat, like I know right away that one of the major rules is that we're not allowed to cross a vertical asymptote. And so I know right now, right off the bat, that my graph, I've got 3 points in a given area here. I know my graph is going to tend towards the horizontal asymptote as x grows to infinity. And I know it can't cross the vertical asymptote, so it gets forced upwards. So I know my graph in that section has to look like that. It's got 3 points. That's lots, right? My job is now, we got to figure out where the rest of the graph is. So I know on any of these particular values of x left of, right? So to the left of x equals 2, I know the graph is in this upper quadrant, as I can see, right? So I know it's not going to be down in here. Now the other thing I got to figure out is where is the graph on the right side of 2, right? So is it up here? Is it going to do something like this? Or is it down here going something like this? I don't know, right? So I know it's going to be in one of these 2 areas left. So I just got to figure that out. One of the ways that I can do that is I know for sure that my graph is going to tend towards the vertical asymptote, right? So I know it can get closer and closer and closer, but never cross. So my question is, where in this window of space is a point on my graph? So what I'm going to do is I'm going to evaluate my function at some point. Like, let's say, this is kind of like not the easiest part of the question because it does take a bit of time to get here, but I'm kind of just, this would be number 6. I'm just evaluating now, right? And so I'm just going to find something on the right side, something close, like, I don't know, you could do 3, you could do 2.5, something that keep you, something that's kind of easy, right? So for the sake of simplicity, why don't I just evaluate the function at positive 3 and see what happens, right? So what that's going to spit out for me is somewhere along that red line, right? I'm going to get a point, and I could plot that point, and then I have an idea as to where the graph actually is. Okay, so let's figure out, either I'm going to get a positive number and a negative number, and it's going to tell me in which part of the graph I'm in, right? So just recalling, okay, we're still dealing with this simplified expression here, and I'm going to evaluate at 3. Okay, so I'm going to go like this. F at 3 is equal to 3 plus 4 over negative 2 times 3 plus 4. So we're going to evaluate, we get 7 over negative 14. Right, because 3 plus 4 would be 7 times negative 2 would be negative 14. That's negative 1/2. So I know that the graph is going to be down here. When x is equal to negative 3, my graph is going to be, positive 3, I'm sorry, is going to be at negative 1/2. Let me just check something here. Something's not right. Huh. What's happened? 3. Did I put that in wrong? Oh, I'm sorry. Sorry. Let's backtrack here. I knew that didn't make sense. Here, let's go back. Sorry. I wrote out the equation wrong. So maybe when you do this too, maybe just rewrite, if you're running out of space like I am, it's just rewrite the function x plus 4. I made a mistake here in rewriting the function, which cost me. Didn't make sense what the value of y I got was. Right? And so what I'm going to do now is just substitute 3, and so it's 3 minus 2. Okay, there you go. Right, so we're going to get 7 over negative 2 times 1, which is, oops, read that in there, which is 7 by negative 2, which is negative 3.5. So the point I'm plotting here is f at 3 and negative 3.5. That's better. Okay, so I can go plot that point. That's down here. Okay, now just to be safe, you can have graphs cross over a horizontal asymptote. But just to be safe, I don't know what's going to happen. Remember, the horizontal asymptote, this horizontal line here, is a measurement of what's happening to the graph as x approaches infinity or negative infinity, basically like end behavior. So what I'm going to do here, I'm just going to pick a point, like an x value, just like I did, like let's say 8. And again, I just want to know, is the graph going to be above or below, right? Either way, it should tend towards this horizontal asymptote. It's just whether or not it crosses over it. Okay, so what I'm going to do is either I want to know if the point's up here or down here, one of the two. Not a huge difference, but does make a bit of a difference if it crosses over the horizontal asymptote. So what I'm going to do, I'm just going to evaluate at f equals 8, or sorry, at x equals 8, and figure out what the value of the function is when I substitute x equals 8. So again, same thing. I'm just going to get a point. I can plot that point in my graph, and then I can connect the points, and I'm done pretty much. Okay, so 8 plus 4 over negative 2 times 8 minus 2. Okay, I should get 12 by negative 2 times 6, which is at 12 by negative 12, which is equal to negative 1. And so my point at f is 8 is equal to negative 1. I can plot that point to be right there. Okay, so I know my graph's going to do something like this. Okay, that is the graph, and that is the process by which you would produce that graph. Again, it looks very daunting. Okay, these questions are very long, but if you follow the kind of 6 or 7 step process that I've laid out here, it's not too bad. Okay, so anyway, that's that question. I will do some more, and you'll do more, and you'll get good at it.